Is my screen visible to everyone?
Yes.
Yes,
Ma'am.
All right. So, a new concept today called thermal expansion. Now, my first question to all of you is that what do you mean by the word thermal?
Heat, something relating to
energy.
heat.
Okay, heat, energy. Anything else?
No.
Okay. So, yes, thermal means anything which is related to heat. All right. Heat. Is there a difference or no?
Ma'am, can you repeat the question?
My
Yeah,
question
your
is,
voice work.
is my voice not clear?
It's more clear now.
Okay. So my question is heat and temperature the same or are they different?
Temperature is the measure of the heat.
Yeah, and it can either be cold or hot.
So isn't that the same as temperature? Temperature is to know whether an object is cold or hot. So
But heat means just something hot.
heat means just hot, is it? No, actually, there is a bigger difference than that. Okay, so to understand the difference between temperature and heat, I would like you to take, and imagine the objects at the molecular level. Do you all know that everything around us is made up of atoms and molecules? Do you all know that?
Yes.
Yeah.
Yes, okay. And you know that the atoms and molecules in solids are tightly bonded to each other. The liquid ones are loosely bonded, and the gaseous ones have no bond with each other.
Yeah.
You know that, right? So, what happens when we supply heat to
Yes.
any kind of matter? Say, for the first case, for understanding, let's imagine we have a solid object. Is my voice audible?
Ma'am?
Yeah.
Yes.
I think I know. I was looking at this because yesterday I was reviewing changes of state, and they mentioned if you add heat to any state of matter, the atoms and molecules will gain energy.
They will gain energy. And what
Yeah.
will happen when they gain energy?
They will break their bonds.
No. I mean, we are
They
not
start
giving it so much energy. We are not giving it so
their
much heat
bond
that it
will
will break the
loosen.
bond.
They
The
So it
start
like
bond,
it kind
vibrating.
of loosens the bond. So like
it loosens the bond. Yes, it does loosen the bond. And what
there's
else?
space for like more for like other substances.
Correct. So
Yeah.
they expand, right? They expand. When the bonds become loose, they tend to go far from each other. So they expand. The volume increases, right?
Yes, right.
Now, do you all know the concept of potential energy and kinetic energy?
Yeah.
You know that, right? So, what happens, whether it's a solid, a liquid, or a gas, all the atoms, all the molecules, even if they are tightly bonded or even if they don't have any kind of bond, they are vibrating by their own positions. Okay, you understand what do you mean by vibration? Yeah, it's a up and down motion or a sideways motion. Like, for example, a pendulum. A pendulum is vibrating by its own position. The same way, the molecules are vibrating in their own positions. When we supply heat to them, the
Hello?
more because they have more energy. Yes.
Ma'am, yeah,
Yeah.
voice and video just stopped.
Yeah, it stopped in the
few
middle
seconds.
and it started.
Okay. Till what did you hear? All right. I'll begin from the starting. So all these molecules of any kind of matter, solid, liquid, or gas, they are vibrating by their own positions. Okay, the vibration can be upwards and downwards, the vibration can be left to right or right to left. Okay, but they are stable in a position, but they're vibrating at that same position, they're not moving here and there. Okay, now when we supply heat to that object, they gain energy, as you all said. Okay, and when the molecules gain energy, they start vibrating faster, they start vibrating more. Okay, so when you are applying heat to any object, you are increasing the amount of kinetic energy in those molecules. Is this clear? Okay, so initially when they are not moving, they have potential energy, and when we are supplying them with heat, they gain energy, and they gain heat energy. And because of heat energy, the potential energy gets converted into kinetic energy, and they start vibrating or moving by their own positions. Is this basic understanding clear to all of you?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay, so when we say heat, we are talking, so when they're vibrating, what happens? One molecule will vibrate, it will pass on some of its vibration to the next molecule. Then that will pass on the vibration to the third molecule. And so on and on. They'll keep on passing the energy to the nearby molecules. Okay, imagine a bus which is fully crowded with people. Okay, and if the brakes are applied really hard, the person who's standing in the front will experience a jerk. Okay, and he moves, and because of his movement, he passes on a portion of that movement, a jerk, to the person standing very next to him. And that way, by transfer of the energy, the last person in the bus will also experience some amount of jerk. Okay, so it is a transfer of energy.
So when heat is applied,
Yeah.
the potential energy is turned into kinetic.
Yes.
Okay.
Okay, so when we say we are talking about heat, we are talking about transfer of energy, not in the molecular level, but transfer of energy from one object to the other object. Okay, so imagine you have two objects placed next to each other. Okay, so you're applying heat to one object, the molecules inside that object start vibrating, and the other object is very close to it, it is almost touching the first object, and eventually that vibration, that energy is transferred to the second object, and it becomes hot over a period of time. Okay, when we are talking about transfer of heat from one object to the other object, we are saying that it is heat. It is not temperature which is transferring, it is heat that is transferring from one object to the other. At the same time, when we say temperature, temperature is just the amount of kinetic energy in one object. So it is how fast the molecules of that particular object is moving. It has nothing to do with whether it is transferred or it is not transferred. Within that object, how much kinetic energy each molecule possesses is the temperature. Clear? Any doubts in this?
Ma'am, your voice broke in the middle. Can you
I
just
didn't exactly
explain?
understand the other voice.
Yeah, the voice broke. Could you just explain it to me, like a brief explanation again?
From the beginning, or you just lost the last part of it?
I lost the last part.
Okay, so what I was explaining is you understood that there is potential energy, then it gets converted into kinetic and all of that, right?
Yeah.
Now I'm explaining you the differentiating factor between temperature and heat. Okay, we say heat when the energy is transferred from one object to the other object. Okay, but when we talk about temperature, we are talking about the amount of kinetic energy which is present in the molecules of one object. We don't have anything to do about the other object or the surrounding for that matter. Okay. When you record your body temperature, do you see how, how the weather is? Are your clothes warm or cold? You just see what is the temperature of your own body. You're not bothered about anything else. The same way, temperature, when you say temperature, it is only related to that one object. It has nothing to do with the other object. But the moment we say heat, heat comes into picture only when there is a transfer of energy from one object to the other object. Is this clear?
Yes.
So, ma'am, temperature is how much kinetic energy an object possesses.
Yes. So if the kinetic energy is more of the molecules, okay, when you're talking about temperature, we are talking about the kinetic energy of the molecules inside that object. Okay. So when the objects have more kinetic energy, the object is said to have more temperature, a higher temperature. Okay. When the object has low kinetic energy, when the molecules have low kinetic energy, the object is said to have low temperature. For example, have you ever observed water when it is boiling, when it is on the flame?
Yes.
The water is dancing, right? It is not steady. It is moving. The molecules are moving up and down and the water is dancing almost, right? That means the water is moving and it has more kinetic energy. That's when it is hot. But when you cool the water, is it moving so much by itself? No, it is not. It is stable, right? So the kinetic energy is less and the water's temperature is also low. Okay? So this picture, if you see, when the object is cold, the vibration is less. You know, these lines represent the vibration. That means it is moving from left to right or top to bottom anyways. Okay? And in the second picture, when the object is hot, it is vibrating more. And imagine what will happen when this ball and this ball, they come close. They will collide with each other, right? So the same way, energy is transferred from one molecule to the other molecule. Is this clear?
Yeah.
Okay. Now, as I just mentioned in the beginning, we will be starting with the activities first, okay? And then we will be moving on to the explanation of it. So I will quickly show you all the, the assembly for each of these experiments. And then Nicola ma'am will guide you through on how to carry out these experiments.
Okay.
So the first experiment that ma'am will demonstrate is the expansion in solids. Okay. So right now you all just remember three things. That's solids, liquids and gases. All the three expand when they are heated. Okay. So first experiment is to check and test the expansion in solids due to heating. So for that, we will be using a ball and a ring assembly, which you all will not have. We will do the experiment when we meet in the lab, but for now, Nicola ma'am will be demonstrating this activity. So what she will be doing, she will have a ring and a ball. So first case, when the ball is cool, it will be easily passing through the ring. But then she will heat the ball, because of which the ball expands and it will not pass through the ring easily. And when will that happen? When the ball has expanded due to heating. That is why it is no more fitting in the same ring.
Like the kinetic molecules are low. So
Sorry?
Because it won't sit through because the kinetic molecules are low.
Because the
right?
molecules are, see, it is expanding because the molecules are moving. Because the kinetic
Yeah.
energy is more, they tend to move a little far from each other, occupying more space. When you say they occupy more space, that means they expand or their volume increases.
Okay.
Okay, so this is the first experiment that you all will do. The second experiment is to observe expansion of liquids on heating. Okay, so for that, this is the assembly. You have to take colored liquid in one glass bottle, insert a straw inside, and seal the mouth of the bottle using some clay. Okay, and then we will be heating the liquid using a candle, and you will observe that the liquid rises inside the straw because we have sealed the mouth, so there's no other way it can come out from. So the liquid height will rise inside the straw, and this indicates that the liquids expand. Okay, this is the second experiment that you all carry out. The third experiment is you have a same glass bottle, but this time it does not have water, it's empty, and you put a balloon on its mouth. Okay, now when it is empty, it is not vacuum, right? It has gas inside, it has air inside it. Now when you heat the bottle, the gas which is inside the bottle gets heated up, it expands, and as a result you will see a slight inflation of the balloon. Okay, the balloon gets inflated because of heating. All right, so these
Okay.
are the three that we'll be carrying out. I will hand it over to Nicola ma'am so that she demonstrates the experiments and you all will simultaneously.
I know,
Yes.
like the past few classes, I haven't been doing the experiments, but today was just not possible. I'm sorry about this, but today was just not possible for me to do the
Oh,
experiment.
don't worry, Dia. You can
Okay,
observe the experiments. I have spoken to your mom, so don't worry about that. Whenever you feel you are ready to do the experiments, you can, make yourself available for that.
okay, thank you. It's just because what's happening around the house, we're a bit busy.
No worries. I completely know the scenario, so don't worry about it.
Yeah, thank you.
Nicola ma'am, over to you.
Ma'am, I don't have clay for the second experiment.
For the second experiment, you don't have clay. What do you have? What kind of glass jar do you have? Glass
Like
bottle?
this one.
I can't see. Yeah. Oh no, that's too wide. It has to be really narrow, like
Like this
you-
one.
that will do. But are you sure it won't break on heating?
I'm not sure. My mom gave me this.
Okay, because not all the bottles are, not all the glass items are heat proof. Some tend to crack when it is heated.
Okay.
Just see if you can do the experiment you carry out, because what happens is when you're heating anything in the glass, the glass has to be really strong so that it can transfer the heat to the item which is present inside it, right? So the amount of heat that you'll be supplying will be a little more. So see the experiment. If you feel that you can do it, you'll do. Otherwise, just observe. Okay. Now keep your videos on. Those whoever is carrying out the experiments, please turn your videos on.
Yeah. So this is ball and ring. Okay. We are using a spirit lamp. First of all, see, the ball easily passes through the ring. Can you all see it?
Yes.
Yes?
Yes.
Okay. So what we'll do now, we will heat the ball. Okay, we'll heat the ball for some time. We need to heat it for about 3 minutes. Then we'll observe what happens. Okay, let's see what happens. Does it pass?
Oh my god.
Wow.
So this happened because what happened? Because the solid expanded. Okay, so it did not pass through the ring. All right. So this shows that solids expand on heating. All right. Did you all get this experiment?
Wow.
Yeah. Okay.
Yeah.
Okay. Now we'll see what happens to liquids on heating. So for this, you need red ink, okay? You need clay, and you need straw and a glass container. All of y'all can put your videos on.
I don't think I'll be able to do this because I think my glass will break if I heat it.
Okay.
Ma'am, is this bottle okay?
What about Adya?
Is this bottle okay?
Show me the mouth of the bottle, Adya. It's too wide. We need a narrow-mouthed glass container.
Ma'am, my dad said this might break, so I think I'll just observe because I don't have any other glass bottle like this.
All right. What about Vedika?
No, my glass bottle will break.
Okay,
if I
Ria.
heat it.
Ma'am,
Okay,
I
Ria
can't
will
do the experiment.
yeah. Okay, fine. So then, what you can do is you can observe. Okay, we need a candle for it, and we will see what happens.
Nicola ma'am, you can use the spirit lamp only. It'll be better.
All right. Okay. So can you see the red ink inside?
Yeah.
Everyone?
Yeah.
Yeah.
So we will try heating it, okay?
What you all have to observe is there is a white colored straw inside the test tube. Okay.
Yeah.
See the level of red color liquid inside the white straw. Can you see it is rising?
Yeah.
That is so awesome.
Yeah, you can see the level of the water inside the straw rising.
Yeah.
Wow.
Yeah, that's really cool.
Okay, one quick question. Where do you think this kind of thing is used in real life? Come on, fast. Where do you see things like this moving inside a straw, moving upwards when heated?
So when it cools, what happens?
Does it like go
In a
down?
thermometer.
Yes.
Does it
It
decrease when it cools down?
yes, it will. When it cools down, the level of water inside the straw will decrease. Can you see it coming down?
Um,
Yeah.
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 Okay. So when
All
it
right. So when
uh,
yeah, Nicola ma'am, you continue.
when it's heated, the liquid expands on heating, and when it cools, it contracts. So it moves down. You can see the level of water moving down, right, from the straw?
Yeah.
Yes.
All right. So tell me the application of this expansion of liquids. It's very, very simple.
In a thermometer.
Precisely. In a thermometer, expansion of liquid principle is used. So what is the liquid in a thermometer?
Mercury.
Mercury. And you all have observed a lab thermometer, right? In the lab last year?
Yeah.
Yes. So in the lab thermometer, what is the liquid?
Alcohol.
Alcohol. So do you observe any difference when you are heating the mercury thermometer, as in when you are measuring your body temperature using the mercury thermometer, and when you're using the lab thermometer to check the temperature of water? Uh, like, can you think of any differentiating factor in the liquid?
Alcohol can't retain the heat as much as mercury.
Yeah, so the alcohol raises and drops very quickly. Okay, but the mercury, it raises very, very slowly, and in a mercury thermometer it cannot come down by itself. You have to give it a jerk, right? So the expansion amount in any liquid will be dependent upon what kind of liquid is it. So if it was water, it rose very, very fast. Alcohol, we know that it also rises very fast, but mercury rises or expands slowly. Okay. All right. So let's move to the third experiment for the day.
Okay. So what we need to take water. Okay. We need a balloon, and a thread has to secure the balloon to the test tube. I I don't think you all can perform this experiment too.
Ma'am, I have a bottle.
You have a bottle, a narrow mouth bottle. Show me, Adya.
Ma'am told us to get this kind of a cork bottle.
Okay, you have a cork bottle, but you need show it to me. All right, yeah, that will work. So but you have to put a balloon to see the change, Adya. Yeah, I don't think it's a very wide mouthed bottle, but see if
Ma'am,
you
I
can,
will check.
yeah, check. Vedika, can you perform this experiment?
No.
How much heat do you have to apply?
Uh,
As much to boil the water. So what you
yes.
can do is, take a little bit hot water so that you don't have to boil heat it too much.
Okay. Let me check.
Can we get it now? Like it'll
You
take,
can,
Yes,
you can
yes.
try it out.
it'll
We'll
take
give you 2
2
minutes to, get your setup ready.
Yeah, I'll get
Okay.
water.
Ma'am, how hot should the water be?
The water can be like just heat it before it boiling. You can put it in the test tube
Yeah,
before
it
it
should be.
starts boiling.
Yeah, before it starts boiling, because only after it boils you will, you'll be able to convert the water into water vapor.
Yeah.
Ma'am, I have heated water now.
Okay. So you can put it in your glass container then. So yeah, put it very carefully
Okay.
into the glass container. Yeah.
I'm ready. Almost.
Vedika, are you ready?
Yeah.
Okay. Adya is, I think she will just be coming. So what you can do, you can do this, okay? You have to tie it with a thread and a balloon should be at the mouth of your container. Tie it tightly with the help of a thread. Yes. Okay, Adya.
How much water has to be in the container?
Take a little bit of water. See, according to your container, it will vary. Okay, at least take half so that it gets heated up, so that the water vapor can. Yeah, don't take too less. What is the length of your container, Gia?
Well, I'm not sure.
You can
I don't
add a little bit more water. At least it should be half. Okay, it should be half of the container. At least half of the container.
I don't
Yes.
think I have enough
Vedika,
water because nothing's happening.
okay. Y'all can take little more than half so that y'all don't have to heat the water more. But it should be at least half, not less than that.
So like this much?
Just put it down, Gia. I cannot. Yes, that will do. Yeah, that's enough. Yes. Yes, Adya, your thing is also all right. Your assembly is good. Gia's is also ready. Vedika, are you ready?
What are you girls going to use to hold the jars?
Yeah.
You can't be holding it with your hand when you're heating it.
That's an issue now. So y'all cannot hold it with your hand.
Do one thing. Do one thing. Are you all logged in from your computer or from the mobile?
Computer.
The tablet.
From the tablet. So Adya, you can take the tablet to the kitchen.
Yes, ma'am.
Yes. So you can hold it in the kitchen with a tong that your mom uses in the kitchen. Okay. And you can heat it in the gas flame when it is very low.
We could also use a double boiler, right?
No, with double boiler, you will not get that 100. It has to reach at 100 degrees, right? Then only the conversion into water vapor will take place.
Yeah, that's why mine don't work.
Yeah. So double boiler technique won't work. You have to heat it properly.
Oh.
Gia, because your bottle is narrow, you can grab a tongue from the kitchen and you can use a candle to heat it.
Okay.
Ma'am?
Yes. Okay, so we can start with it, right? Everyone ready?
You all don't have the other tongue, like which is used to lift vessels.
Ma'am,
This
the
this will
bottle
I
slip.
do,
doesn't
but it's
fit.
in use right now.
Yeah, this is why that's what I was saying, this will slip. It's very dangerous.
Adya,
I'll see.
you
Ma'am,
use the tongue.
the bottle doesn't fit in the tongue. So,
Not at the wide place, like there's a wide gap at the,
yes, ma'am, it doesn't fit there.
it doesn't fit there. Can you turn your this thing on? Do one thing, Adhya. You can heat water in another vessel underneath and put this. Will that work, Nicola ma'am?
It will take a longer time.
Yeah,
It will not show results immediately.
yeah.
But anyways, Adya can try that. It might take a longer time, but eventually she'll observe it.
Yeah. So keep water for boiling in one container, Adhya, and keep your bottle inside that container while the double boiler technique, but at the same time it should be boiling, continuously boiling. Yes, yes, perfect, Gia. Gia, that's perfect. Yes.
Ma'am, I need to start my candle.
Yeah. What kind of candle is that, Gia? You know what? You all can carry out this activity. You all observe Nicola ma'am right now. Okay. And after the class is over, you all can carry out this and try it. Okay. You will get ample time to do it. Nicola ma'am, you can demonstrate.
Okay. So, all of y'all see what happens. So you have to heat the water, okay? Y'all can see the balloon. The balloon is deflated, okay? What happens after some time you can observe.
Ma'am, I can't see the balloon very well.
Um, is it visible now? Now?
Yeah.
Yeah.
Fine?
Yes.
So I'll be heating the water now. We need to heat the water till it starts boiling. You all have to observe the balloon, okay? The balloon is deflated now. You all can observe it. What happens to the balloon? Can you all see the movement in the balloon?
No, not yet.
Yeah.
Ma'am, it's happening here.
Oh, yeah. Very nice, Adya. See? You all can see the balloon?
Oh my god.
Oh, wow.
Adhya, very well done.
Yeah.
Thank
You all can see the balloon?
Oh.
What
It
happens?
kind of burst.
Yeah. So this happens because when heat is provided, okay, the gas expands. Due to the water vapor, The water vapor expanded, and due to that, the balloon got inflated. Okay. So solids, liquids, and gases, whole three of them expand on heating. All right. And then after that, when it's cooled, it will come back to its normal form. All right. Because what happens? The gas is contracting now because of cooling when it is cooled. Yeah. All right. Over to Swapna, ma'am.
Okay, so let's quickly see the observation table. So you will be having 3 observation sheets. Okay, so this is for the gas one, but then all of them you can write what was the initial level and what happened after heating and what happened after cooling. Okay, so in each of the 3 observation tables, you can note down your observation that when expanded, the liquids and the gases expanded, so the level increased. In solids, the size increased, so the ball couldn't pass through the ring. Okay, so note down your observations. Now let's move on to our explanation part. Okay, now a little bit of background we already discussed, that see, solid molecules are arranged and are strongly bonded to each other. Liquid molecules are loosely packed, they are lightly bonded to each other, and gaseous molecules, they don't have any bond. Whenever we provide heat to any of these type of matter, they tend to increase in their volume. By volume, we mean they occupy more space, which means they expand, right? So this is something that we discussed in the beginning of this session. Now, why does it happen? In case of a solid, as I told you, that the molecules are in one fixed position. Okay, when you provide them with heat, they start vibrating by their own position, because of which they tend to push the other molecules and they expand. As a result of the vibration inside the molecules, the solid object tends to expand. Now this expansion is not like, remember the ball, like initially and finally, when you see it with your eyes, you won't feel that the size has changed too much. But when we put it inside the ring, we observed that the ball has expanded little bit, which was very difficult to observe with our naked eyes, right? So the expansion in solids is little less, and this is because of the strong bonds, intermolecular bonds that they have. Okay, they can't break the bonds and go away. You need a lot more heat for that. Okay, so with little bit of heat, the volume does expand, but it expands very, very little. Okay, one example of this is the railway track. Have you all observed the railway tracks ever?
Yeah.
Yeah. So what happens in a railway track? For example, from Pune to Mumbai, we have a railway line. Okay. Is it a same piece of metal track from Pune all the way to Mumbai? No. Right?
No.
They are small, they are built in small segments, and these they are clipped to each other. So this, and while the place where they are clipped, there's a little bit of gap which is given. Next time when you all go to a railway station, you all try to observe this. Now this gap is given because whenever, like, in the hot season, when the weather is very, very hot, the tracks do expand a little bit. Okay, that's why the gaps are provided there. Okay, so is the expansion in solid like understood to everyone of you?
Yes.
Yes. Okay.
Yes,
So
ma'am.
so let's move on to the liquids now. Now the liquids, you all know that the bond between the molecules. Yeah.
Are you by any chance sharing a screen?
Is it not visible?
No.
No, it was not
No, it's
visible.
not.
Oh, okay. I think after the experiment, I missed to share the screen. I'm so sorry. Is it visible now?
Yes.
Yes, yeah.
Oh, what happened? What is this? Okay. All right. So, so that was for the solid. Now for the liquid. The liquids, they have a very loose bond among the molecules. Okay, the molecules are very loosely bonded to each other. So whenever we supply with little bit of heat, the bonds become further loose and the molecules move more farther away from each other. This is why the expansion in liquids is much more visible as compared to that of solid. The volume change in liquid was very clearly visible and it happened also very fast, right? So liquids do expand on heating, and as we discussed, the best example for thermal expansion of liquids is a thermometer, which each one of us has studied and observed. Okay. Now the third is gases. Now what happens in case of gases? The gases work a little differently as compared to solid and liquid. Gases don't have any bonds, okay? And as it is, the gases are moving and they occupy all the space that you have. For example, an empty glass bottle will have gas. The moment you open the lid of the glass bottle, the gas molecules will go and they will kind of occupy the entire room, right? So the gas occupies all the space that is given to it. So how do we define thermal expansion in case of gases? Now imagine an example of your pressure cooker. Okay, your pressure cooker, you know, we put a whistle on top of a pressure cooker. Do you all know that? Yeah. And and you have water inside the pressure cooker. When you are heating, when the heating is started, you close the lid and you put the whistle so that there is no exit for the gas. The gas which is there inside it, which is formed due to boiling of water, remains inside the vessel and the food gets cooked, right? But this gas cannot remain trapped inside. Otherwise, you know, whenever the gas is heated, it expands to its maximum. But the gas or the container which is holding the gas experiences a lot of pressure. Now, in case of a pressure cooker, the gas is inside the pressure cooker. Okay. The gas, when it is heated, the gas wants to come out. It wants to expand. But because of the walls of the pressure cooker, because of the lid of the pressure cooker, the gas cannot come out. So we put the whistle so that when the pressure increases beyond the limit, the pressure cooker will give a whistle. The whistle gets lifted due to the pressure and we see the hot gas coming out. As soon as the pressure reduces, the vessel again settles down. And again, it heats for some time and again it gives a second whistle. Okay? Do you all understand what I'm saying?
Yes, ma'am.
Yeah. So this is what happens in case of gases. The gases expand, but while expanding, they exert a lot of pressure on the container in which it is stored. Okay. So because they are not bounded by any kind of bonds, they beyond boundaries. They want to take up all the place. They want to increase in the maximum volume they can, and a lot of pressure is formed. Okay, is it clear? Like the expansion in case of solids, in case of liquids, and in case of gases.
Yeah.
Do you all understand all three of it?
Yes.
Yeah.
Yes.
Yeah. So the solid example I gave you was a railway track. For the liquid, a thermometer. And for gases, the example is a pressure cooker. Okay. Next time when you are in the kitchen, observe the working of the pressure cooker. Have you all ever heard about, pressure cooker bursting?
Yes, ma'am. If you let out the steam earlier, it'll burst.
No,
Before it,
no. Whenever, have you, the place where we put the whistle, it's a open straw kind of a place, right? It is open there. And to close it, we put a whistle. Observe the pressure cooker after the glass, okay? What happens is we put the straw and on top of it, we put the whistle.
Ma'am, your voice is breaking. I didn't hear anything.
Is it audible now? Is it better?
Yeah.
Yeah, but at
Yeah.
times it breaks.
yeah,
It breaks?
times it,
Okay. So just tell me to stop talking. So I'll myself.
it broke again.
But now it's okay.
Okay.
It
All right.
completely stopped when you said observe the pressure cooker.
Okay. Is it audible now? Am I audible?
Yeah.
Yeah. Okay. So I was observe the pressure cooker. Okay. It has a small straw kind of a thing which is there on the lid of the cooker.
And it
It
broke.
happened
Now
again.
that is a open. Yeah. That is. It broke again. Just give me a minute now. I'll change my Wi-Fi connection. Just give me a minute. Am I audible?
Yes.
Am I audible? Better now?
Yes.
Yeah, okay. Yeah, so in that straw kind of a thing which is there on the lid of the pressure cooker, if something gets stuck, if it gets blocked due to any reason, okay, that is the time when the pressure cannot come out from that opening, and as a result, your pressure cooker bursts. Okay, because there is no way that the hot gas can come out and release the pressure. So as a result, the bursting of the pressure cooker takes place. Okay, so these are real life examples of thermal expansion of solid, liquid, and gas. Okay, let's quickly move on to the next slide and see what happens. Okay, now see, when the temperature is less, the vibration is less. When the temperature increased, the vibration increased. When the temperature is at 40 degrees, the vibration is the highest among the three cases. Okay, so the vibration, see, the bonding is still there. The bond is not broken yet. The bonding still remains, but they are vibrating by their own positions. So this is what happens inside the solid matter, liquid matter, as well as gaseous matter. Okay, at a molecular level, they are vibrating like this. Okay, clear till now?
Yeah.
Yes.
Yeah.
Ma'am, in the pressure cooker, why do we put the rubber thing?
So that there is no escape for the gases. If you don't put the rubber ring, it won't be a pack seal. See,
Oh,
whenever gas can escape from very small opening also. By putting a rubber ring, we are ensuring that all the hot gas which is created inside the cooker while heating remains inside, so that the food gets cooked. If you don't put the ring, then it won't work. The gas will escape from the opening. There'll be slight opening between the lid and the bottom of the cooker, so it can escape from there, and as a result, the food will not be cooked.
okay.
Okay. Now, thermal expansion happens in many ways, okay, depending upon the shape of the container. Now we saw that the ball, the size of the ball increased. That means the increase in the area or volume of the ball. Okay, increase in the area. You all know what is area, what is volume?
Yes.
Yeah. So area means when you keep it somewhere, how much place it occupies. That is the area, right? So you saw in solids, because of the shape, because of the ball, the shape of the ball, the size of the ball increased. When you say the size of the ball increased, the area of the ball increased. Okay, so this is area expansion due to heating. Okay, When you say volume, in case of the liquid, the straw thing, you observed that the shape did not change. Only the volume changed. The volume expanded, right? So this is volume expansion in case of liquid. Similarly, when you will heat, say for example, you will heat a small a needle or something like that, because of its shape, the expansion will be linear. That means the length will increase or the width will increase. Okay, so there are, depending upon the shape of any object, three different types of thermal expansion can happen: the linear expansion, area expansion, and the volume expansion. Okay, is this understood?
Yes, ma'am.
Okay, now see, these are the examples which I gave you. These are the railway tracks.
Ma'am, your voice broke again.
And I can't hear you.
Which they have used. Okay, in between there is a small
Your
gap.
voice is breaking.
Okay, so still better.
A bit better.
Am I audible now? Am I audible now? Is it better?
Yeah, it's better.
Yes, it's better.
Okay. So two railway tracks, and in between you can observe a small joint. This is because the solids expand. Okay. And this we already discussed, that the liquids molecule, these are the molecules of mercury which are expanding in case of a thermometer. And this expansion in liquids is more than that of the solids. Okay. The third is the gases. So a gas balloon raising up is also an example of thermal expansion of gases. Okay. Is this clear?
Yes, ma'am.
Okay, now I'm going to tell you one activity which you all have to write down, and you all have to find out answer for it. Okay. Now we studied that all the solids, all the liquids, and all the gases expand on heating. Okay. I will tell you that water does not expand on heating. Yes, we did see that the water expanded, it raised in the straw, but up to some degrees, when you heat the water, up to some degrees, the water does not expand. Okay, so read about it and tell me in the next class, what is this behavior?
Ma'am, your voice
Ma'am, your
broke.
voice broke.
Okay, so my question is that water expands heating, but it does not expand for certain degrees of temperature. It does not expand, and beyond that it starts. So you all have to study about the properties of water and tell me at what temperature the water does not expand and why does it happen that way. Why does water behave differently than other liquids? Okay, and what is the
So
application?
research about it.
Yeah, you can research about it, you can read books, you can do, ask your parents, any which ways. It's not an exam. You'll have to study more about it.
Okay.
Okay, so maintain a notebook or maintain a few sheets of paper along with your experiment sheet, where you can write down the question that we give to you every week, and Google it, research it, study about it, find out the answer, and write the answer on the sheet and send a picture to us.
Okay.
Okay, ma'am, but what's the question again? I'll just get a book.
Okay, the question is that we studied that the liquids expand on heating. Okay, water
One minute.
Yeah. Should I start?
Yeah, go ahead.
Yeah. So liquids expand on heating,
Okay.
but water behaves a little differently than other liquids. Okay. Water does not expand from, like when you are heating water from 0 degrees to 20 degrees, it does not expand up till 4 degrees. So 0 to 4 degrees, the water does not expand. And beyond 4 degrees, the water starts expanding. So why does water behave like this? Is the first sub question. Second question, what is this behavior of water called? Okay. And the third sub question is, where do you see application of this behavior of water?
Okay.
Okay. So three sub questions. Why does water behave like this? What is this behavior of water called? And where do you see application of this behavior of water? Okay. So you're me by Saturday every week, whatever question you can send us the answers by Saturday. Right?
Okay.
Okay. Was the class understandable?
Yes.
Did it go well?
Yes. Yeah.
Yeah.
I like today's class.
Thank you so
Me
much.
too.
Thank you. All right. So we will see you all next week now.
Yeah.
Okay. All right. Bye-bye.
Bye, ma'am. Thank
Bye-bye.
you.
Thank you.
Bye.
Bye-bye.
Bye. Thank you.
Bye.
Bye.
Bye.